this with an interval notation and starting our table. Can anyone replace this with an interval notation for us?
True.
You mean negative infinity to 3. And let's replace this by the interval notation. Anyone?
3 to infinity.
Yes, awesome. So we need to find the domain first. Based on this, what is the domain? Because I don't know what to put here if I don't find the domain. First, I have to find the domain. What is the domain? Based on the intervals we see. This may be more difficult to understand or find a domain from, but this is easier, I think.
Do you start with putting 3 in the middle?
0 is always in the middle. We want 3. Yes, that's fine. That's fine. I know what you mean. But 0 also has to be in the table. Good. But
Would you do parentheses negative infinity comma 3 close parentheses?
Not close parentheses because there is no
I'm sorry,
equals.
open,
Yes.
parentheses,
Yes. Excellent.
union.
Indeed. So negative infinity to 3, union 3 to infinity. Perfect. This is the domain. In other words, does the function exist at 3 or it does not?
No, it
It does
doesn't.
not.
Very
does
good.
not.
Very good. We are going to put exactly this parenthesis and this parenthesis to the left and right and nothing in between. Undefined. Good. So negative infinity to infinity. Perfect. Thank you. Thank you so much. Which function we use between negative infinity and 3? I know it's silly, but I just want to make sure because these may not be presented in the correct order. So I need to identify which function goes with which interval. So which function goes with this interval? Please.
Would it be x minus 3?
So that's exactly why we're doing it, right? So greater than 3 is x minus 3. Is that okay? Yes?
Yes.
Perfect.
The other-
Yes.
Yes, that's okay. That's
Negative.
if you know this stuff, then we don't need to be here, right? So make sure that negative infinity to 3 goes with negative x plus 4, and 3 to infinity goes with 3 plus infinity. Awesome. Perfect. So now we have to plug in some numbers. So when I plug in 0, what do I get?
4.
Yes, awesome. When I plug in 3, and I know you will be appalled, and you will say, no, you are not allowed to. True. But I will put it in. Yes. So when I plug in 3, what do I get?
7.
Careful. It's negative.
1.
Yes, that's okay. Inside the parenthesis. Perfect. Now let's plug in 3 here.
0.
Excellent. And because it's linear, we need another point. So I'm going to put in 4. And if you plug in 4, what do you get?
1.
Perfect. If you understand this table, you will immediately, without even graphing, give me the limit as x approaches 3 from the left from g of x. Look here and identify the limit. We're going to graph it, of course. The limit from g of x as x approaches 3 from the left. What should I write? Exactly 1. The limit from g of x as x approaches 3 from the right. What should I write?
0.
Excellent.
0.
What is the unique number, if there is one, as the limit of g of x as x approaches 3 from either side?
DNA.
Thank you very much. Indeed. We are ready to graph, although we don't even need it because we already have the answer. But it's asking us to graph, so let's graph. Make sure nothing overlaps. It will not be a function. I'm going to use 2 different colors, whatever this is and whatever this is. Okay, so 0, comma 4. 0 for x, 4 for y. 3, comma 1. 1, 2, 3, 1. Open point. Open point. Because this is not a bracket. Connect and do not extend to the right, but you can extend to the left if you want to. I'm done with this. Now, 3, comma 0. Open. Four, comma 1. You do not have to graph these functions with 2, 5, 10 million colors. No. The reason I'm doing this is because I want you to understand that you cannot extend this color here and you cannot extend this color here because this is not going to be a function anymore. Now it is. And we identify the answers. The limit from the left, of course. The limit from the left is 1. Of course, the limit from the right is 0. But what is the unique number, like here? The unique number. I was able to say 1, done, it exists. I was able to say 0, done, exists. But here I'm not able to. Because I cannot tell you, oh, it's a combination between 1 and 0. No, I have, the limit exists if the answer is a unique number that I can give. I can't. Awesome. Good. I think we can move on to talking about algebraic limits. Okay. So that's my page 7. So in 1.2, algebraic limits. So notice one thing what we did so far. We looked at graphs and we identified the limits. We created a graph, although we shortcutted it because we already had the answer. But we created the graph. We were given a function. We created a graph and we were able to identify limits. But now we want to do it algebraically. There are so many different functions, so many different ways. One thing I want to mention from the beginning is the limit as x approaches a number. Left, right, either side, it doesn't matter. From a polynomial. Remember, polynomials are first degree, second degree, third degree, and so on and so forth. Is always that function at a. And you could say, and I would have to say you're right, wait a minute. You told us when x approaches a, meaning x does not equal a. So if this polynomial is f of x, what you're doing here, you're equating, you're setting equal the limit with the function value. You just told us that they are not the same. You just said that the limit here exists, although the function value does not. So the function is undefined at 4, but the limit exists at 4. So why are you setting these two equal to each other? They are not meant to be true. The limit is the tendency. The function value is something else. But it happens that this is true for polynomials. Here's an example. If I'm asked to find the limit as x approaches 3 from 2x plus 1, all I have to do is plug in 3. Why? Because this is a polynomial. Can anyone give us the answer?
Seven.
That's it. Thank you very much. So this happens for polynomials of any degree. Now, what about I have the limit of the square root of x plus 1 when x approaches negative 3? So I am going to cover this for a moment. See, first of all, here I identified it's a polynomial. I am allowed to plug it in. Here I have a radical. I need to find the domain of the radical first. If I cannot find the domain of the radical, I cannot apply this limit. So forget about the limit now and tell us, anyone, How do I find the domain of this function? And remember, we discussed that last week and before. What do I have to write? Remember, condition, solve
Greater or equal to 0.
solve the condition, and then domain. Yes, greater than or equal to 0, but you have to tell me what.
X plus 1.
Exactly. So I move 1, so I have x greater than or equal to -1. So the domain is -1 to infinity. Perfect. Now I can identify the answer. What will you say?
-2.
What do you say?
Does not exist.
Thank you very much. As we know, the square root from a negative number is not a real number. -3 is nowhere near in the domain. So therefore, there is no answer. Or their answer is D and E. Now I'm modifying the same thing again. I'm using the same function. What will you say now?
The domain would be the same.
So the answer?
4.
Careful.
2.
Exactly. 3 is in the domain. If it is in the domain, I'm using the same procedure as if it were a polynomial. If it's not in the domain, if -3 is not in the domain, for a radical function, I know what I have to write. But since 3 is in the domain, all I have to do is plug it in. 3 plus 1 is 4. The square root of 4 is 2. Polynomial, radicals. Now if I have this, limit Sx approaches -3 from the cube root of x minus 5, what will you say? First of all, I'm going to ask, what about the domain of this function? What is the domain of a radical with an odd index?
-∞.
Excellent. These are friendly. Thank you so much. Who was that? Thank you. We never have to state restrictions when the index is odd. So then, I have no problem. What is the answer?
Is it 2?
But 2 cubed will not be -8.
Well, since it's -∞, when it going back to the not exist L.
This only says that you can plug in anything. There is never DNE.
-2.
-2. The answer for the limit of the cube root will never be DNE of the situation like this, because the domain is all real numbers. You can always plug it in blindly. There is no problem because it's index 3. Good. So we talked about polynomials, how to determine the domain. We talked about radicals, how to determine the domain. Remember, the limit. How to determine the limit. How to determine the limit of this. You have to find the domain first. Not here. I wrote it, but there is no need to find the domain because it's odd index. Plug it in and get whatever you get. You get a number. The domain, 3 is in the domain, plug it in. If 3 is not in the domain, DNE. So now I wanted to look at a rational function. So let's say f of x equals 1 over x. And I want to determine the limit as x approaches 4 from 1 over x. Is 4 in the domain? Pretty much same idea. Is 4 in the domain? Yes. What will not be in the domain?
-4.
I can divide 1 by -4. There is no issue there.
0.
Yes, 0 will not be in the domain because I cannot divide 1 by 0. Remember, I still have this from last time. Where is it? Please remember, this is the problem. Anything not 0 over 0 is undefined. Perfect. So same idea. Plug it in. If this number is in the domain, blindly plug it in. You're going to get the answer. What is the answer? Anyone?
DME.
So if the number is in the domain of this function, it's the same idea with plug it in. So what is it?
1 over 4.
That's it.
1.
1 over 4. Now I'm changing the problem again. So limit as x approaches 0 from the left of 1 over x. And limit of 1 over x as x approaches 0 from the right. Okay. It's 1 over 0. So initially 1 over 0, we know that this is undefined. The limit cannot exist. No way. Same thing here. 1 over 0. So no matter what limit we are given, we should always, at least in our mind, and write it like I do, plug it in first. So here I plug it in. Of course, it's not 0. The answer is 1/4. I'm done. So here when I plug in 0, I get 1 over 0. And I know the answer cannot exist. But when we say it cannot exist, so a number divided by 0 is undefined, but the limit can be 3 different things. The answer for undefined in this situation can be for the limit. So limit, maybe I should put it like this. As x approaches a of f of x, if it is a number over 0, then it can have 3 different faces. One is negative infinity, the other one is infinity, and the last one is DNE. Only one of them. Only one. So, what is the answer here? I know I have to finish. This is it. These two, and I'm done. So 0 from the left. 0 from the left is negative numbers. 1 over a negative number. What is the sign? 1 over a negative number. What will the sign be?
Negative.
Perfect. Which of these 3 options do I have to put here? So we said that 1 over a negative number is negative. Which of these 3 is the only one that fits the answer?
Negative.
Negative infinity.
Exactly. Then for this one, 0 from the right is positive numbers. What is the sign of 1 over positive?
Positive.
Which one of these, only one, which one of these 3 fits the answer?
Infinity.
Yes. Final question. Limit of 1 over x as x approaches 0 from either side. This was from the left, this was from the right, and now from either side. Which of these fits only one?
DNA.
Exactly. So 1.1 is complete, but 1.2 is not. So I need time to finish up 1.